Okay, but as you know, we started topic redox reaction. Okay, and we do some definitions, basic definition. What is redox reaction? What is oxidation and reduction? And then we discuss what is meant by a reduction. We define reduction, or we know reduction involves three steps, three things. Okay, if there is loss of oxygen, if there is gain of hydrogen, if there is gain of electron, or decrease in oxidation state. Okay, that is reduction. And oxidation is opposite to it. Oxidation involves loss of hydrogen or removal of hydrogen, whereas oxidation is gain of oxygen or addition of oxygen. And third, that is loss of electrons or increase in oxidation state. I told you that you can use word RIG rig. Okay. What is rig, beta? Mariam, do you know?
Like a reduction in like
Reduction is gain of electron. Okay, reduction is gain of electron. And what is oil? Yes, Abdullah. Oxidation is loss of electron. But O for oxidation, I for is, L for loss. Okay. So I told you that, for example, you have an atom A, okay, and you have an atom B. If this loses electrons and give electrons to this B atom, this will gain positive charge. Okay. It was electrically neutral before losing electrons. Okay. It was just an atom, but after loss of an electron or after transferring one electron to this B atom, it has gained positive charge. So its oxidation state number has increased by 1. Now it is +1, 0 to +1. And B, after gaining electron, has gained -1 charge. Okay. So this is losing electron, this is being oxidized, and B is gaining electron, B is being reduced. Okay. So we would say that A has undergone oxidation and B has gained electron that has undergone reduction. Okay, beta? Abdullah, did you get this or not? Abdullah.
I would like a re-explanation.
But I told you that rig is for reduction. Reduction is gain of electron. Okay, and oil is for oxidation. Oxidation is loss of electron. Okay, so these are the simple words to remember these two things, because this is important in reduction and oxidation, that it involves loss and gain of electron. So reduction means reduction is gain of electron. When any atom or an ion gains electron during a reaction, we will say that it has undergo reduction. Whereas when an atom loses electron or transfer electron to other atom during a reaction, it loses electrons, so it gains positive charge, or its charge, if it is already positively charged, but its positive charge is increasing, we would say that it has undergo oxidation due to loss of electron. So oil mean oxidation is loss of electron. Reduction, rig mean reduction is gain of electron. Okay. Now I will explain it to you with few examples. Okay.
Okay.
You have to wait for me for a second. Okay. So for example, we have this very common reaction, zinc plus, if we have copper 2 sulfate solution. Okay, it forms zinc sulfate plus copper. Okay. You know, zinc metal is over here. It is uncombined in free state. We have added it to an aqueous compound of copper 2 sulfate. It forms zinc sulfate, and copper is being separated from its compound. So this is another type of reaction which when we discuss the different type of reaction, I told you that when one element displaces another element, that is called simple displacement reaction. Do you remember?
Yes, sir.
So this is simple displacement reaction, Abdullah. Now, why this is happening? Because zinc is more reactive than copper. When you add zinc to copper to sulfate solution, copper to sulfate solution is blue in color. This is blue in color, okay? It changes blue to colorless and forming a pink or brown solid. That is copper. Okay, is it clear?
Clear.
So zinc is displacing copper from its compound to form zinc sulfate plus copper. Now, the charge on zinc over here is zero because it is uncombined state. Okay, it hasn't combined; it is in free state. After this reaction, when copper in this compound copper to sulfate, copper has plus 2 oxidation state.
Sir, your voice is unclear.
Not clear?
Yes, sir.
It should be clear, beta. Now, can you hear me?
Yes, sir.
Okay. So look at this, beta. Zinc has zero oxidation state here. It has zero charge. Whereas copper to sulfate, copper has plus 2 charge. Sulfate has overall minus 2 charge. After this reaction, zinc has gained plus 2 charge, sulfate has minus 2, and copper has zero oxidation state or zero charge. So why, Mariam, why copper has zero charge over here in this side, right side of the equation? Ji, Mariam. Mariam,
It's because it's not like it's not like uh,
it is in uncombined state, beta. It is free element now. It is free element now. Okay, it is not part of any compound. It is free element. Okay, it has zero oxidation state. As I told you yesterday, when I explain you the rules of oxidation states or oxidation number, I told you that when any element is in an uncombined form or exists as an atom, okay, in free state, it has zero charge or zero oxidation state. But when it loses or gain electrons while making compounds, then it lose or gain electrons. Then it have certain oxidation state like +1, -1, +2, -2, like that. Okay, is it clear?
yes, sir.
So this reaction is a redox reaction because zinc is losing electron. You can see zinc 0 to +2. Abdullah bhai, here you can see that zinc is losing electron during this reaction. It changes from 0 to +2. It means it has lost electrons. Did you get this or not?
Yes, sir.
Abdullah, zinc has lost electron because it was having zero charge when it was in the left side and the reactant side. But after this reaction, zinc has made its compound zinc sulfate. So zinc has gained +2 charge. Now we would say that it has oxidized by the loss of electron. Okay, is it clear?
Okay.
Whereas
Yes.
what has happened with copper? Copper has gained electron beta here, +2 to 0. It means it was already having lost 2 electrons here, but after the reaction, it has gained back its electron, and now it is in zero. It is having zero oxidation state. So we would say that it has gained electron. It has reduced now. Okay, is it clear?
Yes.
So this reaction is a redox reaction because zinc is losing electrons to become oxidized. Copper is gaining electrons to become reduced. So oxidation and reduction are taking place simultaneously in this reaction. So this reaction is a redox reaction. Okay. Okay, beta.
Okay, sir.
So most of the displacement reactions are always redox reactions. You should keep in mind. Okay. redox reactions, all displacement reaction are redox reaction. Okay.
Okay, sir.
Clear? Simple displacement reaction in which one element displaces another element from its compound. That is called simple displacement reaction, and simple displacement reactions are always redox reaction. Okay.
Okay.
Now I will explain it with another example that is related to loss and gain of oxygen. Okay, beta? So you should know what is meant by loss of oxygen and gain of oxygen. Abdullah, better go through your notebook, what you have written about oxygen. When a compound loses oxygen, we would say that it has reduced. It has undergone reduction. Okay. Whereas when atom gains oxygen, we call it has undergone oxidation or it has been oxidized. Okay. Is it clear?
Yes.
Okay. Now I'm going to write an equation here that involves loss and gain of oxygen. Okay. For example, we have this compound Fe2O3. Fe2O3, okay, plus carbon monoxide. It changes into iron plus carbon dioxide. Okay. This equation is already balanced. You can check the number of atoms of each elements are equal in both sides. We have 2 iron in this side, we have 2 iron in this side, we have 3 carbon, we have 6 oxygen here on this side, 3 plus 3, and we have 6 oxygen. Okay. So oxygen atoms are balanced and rest of the elements are also balanced. Okay, beta? Okay, Maria.
Sir, your voice was unclear.
Now I don't know why, but it is my internet is very fine. I'm using Netel. Okay, so Mariam, can you hear me now?
Yes, sir.
Okay, so look at this beta here. Oxygen has, sorry, this compound has oxygen. This now here iron has no oxygen. Here it was carbon monoxide having 1 oxygen, but here it is carbon dioxide is having 2 oxygen. So how do you know that it is a redox reaction with reference to loss and gain of oxygen? Who can explain, Abdullah or Mariam?
Sir, can you repeat?
Beta, how it is a redox reaction with reference to loss and gain of oxygen. Okay.
Okay.
Now you can hear me.
Yes, sir.
Very good. So you have to explain how it is a redox reaction with reference to loss and gain of oxygen. Which substance is being oxidized, which is being reduced in this reaction. This is very simple. Iron 3 oxide reacts with carbon monoxide to form iron plus carbon dioxide. Okay.
Okay. So like iron is being reduced and uh, carbon monoxide is being oxidized.
Yes, good. We would say that this whole compound Fe2O3 has been reduced by the loss of oxygen. Reduction. This is reduction, okay? Due to loss of oxygen. This compound has lost oxygen. Whereas carbon monoxide has gained oxygen, Abdullah. So this has undergone oxidation.
Okay.
Okay. So in this reaction, iron 3 oxide has reduced by the loss of oxygen, whereas carbon monoxide has oxidized by the gain of electron. So oxidation and reduction are taking place simultaneously. Hence, it is a redox reaction. Clear?
Okay.
Okay, Abdullah. Mariam, it is clear?
Yes, sir.
Okay, good. Okay, now I'll give you another example and you have to tell me that whether it is oxidation reduction or how it is a redox reaction, okay? Yes, Mariam and Abdullah, please note down this equation in notebook. First, note down this equation, beta.
Okay, wait.
Done, sir.
Okay. Yes, tell me how it is redox reaction, beta.
Carbon is being
Ji, beta. Now tell me.
so like carbon is being oxidized and zinc is being reduced.
Yes, carbon has been oxidized by the gain of oxygen, whereas zinc oxide, beta, we call it zinc oxide, that has reduced by the loss of oxygen. Okay, is it clear? So this is
Yes, sir.
reduction. This is reduction, and this is oxidation. Okay, zinc oxide has been reduced by the loss of oxygen, whereas carbon has been oxidized by the gain of oxygen. So overall, it is a redox reaction. Overall, it is a redox reaction. Abdullah, did you get this or not? Ji beta. Hello.
Sir Abdullah disconnected.
Okay. Now where is Abdullah?
Yes,
Can you hear me, beta?
yes, I can.
Okay, good. So did you understand that how this is a redox reaction? Zinc oxide plus carbon makes zinc plus carbon dioxide.
Yes,
Please explain.
Okay, so basically, is the zinc, it reduces, basically reduces uh, into 2Zn, while the carbon dioxide it oxidizes into CO2. It takes the oxygen from zinc oxide into carbon zinc oxide to make carbon dioxide.
Yes,
Uh,
it's fine. It's fine. Okay, let me explain it to you once again. Because zinc oxide here, ZnO, that is a compound of oxygen. It is using oxygen to form zinc. So zinc oxide has been reduced. Okay, zinc oxide has been reduced, whereas carbon has been oxidized by the gain of electron. So that is oxidation. Okay, gain of oxygen. So zinc oxide is losing
Okay.
oxygen, whereas carbon is gaining oxygen. Zinc oxide is losing oxygen, so it has reduced. Carbon is gaining oxygen, so it has been oxidized. So reduction and oxidation are taking place simultaneously. So it's a redox reaction. Okay, clear, beta?
Yes, sir.
Okay, good.
yes.
Now I will ask a question that how oxidation reduction is taking place. Reference to loss and gain of electron. Okay.
Okay, sir.
For example, we have Mg plus HCl. Okay, it is forming MgCl2 plus H2. So I think we should have a copy of periodic table with you, that you should know where is magnesium in the periodic table, where is hydrogen, where is chlorine, like that. Okay. So in order to balance this equation, I'm going to put 2 over here as a coefficient. This is solid, this is aqueous compound. This salt is in the form of aqueous solution and gas is bubbled off during this reaction. Okay. So this is complete and balanced equation with state symbols. Okay. Now, in order to explain that whether it is redox reaction or not, and how it is redox reaction, if it is redox reaction, how it is redox reaction, we need to put the oxidation state first of all on all elements. Okay, beta? Okay.
Okay, sir.
As we know, magnesium is in group 2, but over here it is an uncombined element. It has zero oxidation state. It has value of charge 0. And hydrogen chloride, as we know, hydrogen has mostly +1 oxidation state. So chlorine will be have -1 in order to make it equal to 0. And I already told you that halogens, group 7 elements, have -1 oxidation state in their binary compound. So this is a binary compound. HCl is made up of 2 elements, hydrogen and chlorine. And chlorine is halogen that has -1 charge. Okay, beta?
Okay, sir.
Okay.
Okay. And this is the compound of magnesium chloride, and magnesium is in group 2. It has +2 oxidation state because it is in group 2. Chlorine here has -1 oxidation state because it's a binary compound, and halogen has -1 charge in that case. And hydrogen is it is a diatomic molecule. It has oxidation state of 0. So this is how do we put the oxidation state before knowing that whether it is oxidation or reduction, or which element is being oxidized, which element is being reduced. Okay, it is a redox reaction because it is a displacement reaction as well, because magnesium is displacing hydrogen from acid to make salt plus hydrogen gas. Okay, and oxidation states are also being changing. You can see that oxidation states are changed. Okay, and the reactant side and the product side. Okay, beta.
Okay.
So now Abdullah will tell me that which element has been oxidized and why and how. Yes, Abdullah bhai.
Okay. So the okay. So basically, the H it's like reduced. It gets like you can say it gets like reduced as the magnesium takes its place to make magnesium chloride. So like the hydrogen, so leaves out the hydrogen. It displaces the hydrogen out of it, and which also reduces it to have like a neutral charge. Uh, then the magnesium basically since magnesium has plus two is a plus two ion, it therefore the to make Cl2 like two and one, it two there's like more two and thus therefore the chlorine there's like more chlorine too. Yeah. This is also why there's also H2 at the like end plus H2 because it needs because the reactants are two HCl functions.
Okay, Abdullah. Okay. Let Mariam to explain this. Mariam, can you explain this in very simple way? But it's very simple. It's very clear from the equations that how one of the element is being oxidized and the other element is being reduced in this reaction. Ji, Mariam.
Chlorine is being oxidized because there is a loss
No. Wait. The chlorine has in both the side -1 oxidation state. So there is no change in oxidation state of chlorine in both the side of equations. Chlorine is not being oxidized or reduced. That is not changing its oxidation state. Here, you can see magnesium has 0 oxidation state here. On the left hand side, being a simple or free element, single element, but here it has +2. It means it has lost 2 electrons during this reaction. So this has been oxidized. This is oxidation. This is oxidation. Okay, beta?
Okay, sir.
Okay.
Sir, I have a question. It's like yesterday we wrote down the rules of oxidation that like there's a loss of hydrogen like in oxidation. So
No. I told you that in such an equation in which only hydrogen is lost by one element, one compound, but not from the other compound is gained. So we would not say that it is a redox reaction. Okay. Is it clear?
okay.
It's a displacement reaction that magnesium is displacing hydrogen from its compound. And displacement reaction are always redox reaction because the element which is displacing the other element will undergo oxidation and the element being displaced will undergo reduction by the gaining electron. So magnesium is being oxidized by the loss of electrons. Hydrogen here is gaining electron. Okay. Its oxidation state is changing from +1 to 0. So that is reduction. That is reduction. Okay. So magnesium has been oxidized, whereas hydrogen has been reduced by the gain and loss of by the loss and gain of electron respectively. So this is a redox reaction. Okay. Is it clear?
Yes, sir.
Now I'm going to explain this once more, beta. Magnesium is losing electrons to form Mg+2. Okay. Whereas hydrogen ions from acid gains electron to form hydrogen gas, that is overall oxidation state of 0, being a diatomic molecule. So that has been reduced. So magnesium has been oxidized, whereas hydrogen ion has been reduced by gaining electron. So that is the reduction. And magnesium has been oxidized, that is oxidation. So both oxidation and reduction are taking place simultaneously or side by side or all together in this reaction. So this is a redox reaction. Is it clear?
Yes, sir.
Okay, beta Abdullah, clear?
Clear.
Okay, good. Now I'm going to write another equation, but that is also redox reaction with reference to loss and gain of electrons. Okay, but I think before going to discuss that, we should have an equation in which one element is losing hydrogen, other is gaining hydrogen. Okay, clear? One of the compound is losing hydrogen, and other substance is gaining oxygen. Yes, beta Mariam. This compound is methane. It burns an oxygen to form carbon dioxide and water. In combustion reactions are also oxidation reaction. You can explain this reaction with reference to loss and gain of hydrogen as a redox reaction. So how can you explain this, beta? Yes, Mariam. Mariam, are you there?
Yes, sir.
Can you explain this reaction, how this is a redox reaction with reference to loss and gain of hydrogen? It's very simple, beta.
Okay, sir. So like
Here, methane is
methane, yeah, methane is like losing
hydrogen. Yes.
like
You can say this is loss of hydrogen. Loss of hydrogen. Okay, so this is oxidation. This is oxidation. But here, oxygen is gaining hydrogen. This is gain of hydrogen. Gain of hydrogen. This is reduction. Okay, so methane is going to oxidize here, and oxygen is being reduced over here by gaining hydrogen. So this is also a redox reaction with reference to loss and gain of hydrogen. Did you get this or not?
yes, sir.
G. Abdullah, did you get this?
Uh, okay, yes, I get it.
Okay. Now I will write another equation, but Phil, you have to explain that how it is a redox reaction. Definitely it will be a redox reaction, but you have to explain that how it is a redox reaction. Okay, Mariam.
Yes, sir.
But for example, we have this compound copper 2 oxide. It is black solid, if it is heated with steam of hydrogen gas, okay, it changes into copper, that is pink solid, and steam is being formed, or water. Okay,